Hello everybody. In today's video, we're going to be looking at what we call the normal distribution and the empirical rule. And then we're going to be using both of this graph right here to calculate probabilities where you actually have a normal distribution. So a normal distribution is one that follows this kind of shape. So for example, think about heights. The average male height is about 5'10". So you would expect most males to be round about there at 5'10". But as you get taller, you would expect fewer and fewer males to be that particular height. So right up here, maybe this is about 6'5". You would expect fewer and fewer males to be 6'5". And likewise, you would expect fewer and fewer males to be, say, like 4.2 feet tall. So when you put all those heights together, you get something called a normal distribution. And the normal distribution really describes a lot of variables out there in the world, like weights, income, various things like that. Now, a really interesting part of the normal distribution is something called the empirical rule. And basically, if you got a whole bunch of data and you were to graph it, you would find that 68% of the data would normally lie within one standard deviation of the mean. 95% of all the data would lie within two standard deviations of the mean, and 99.7% of the data, so that's pretty much all the data almost, would lie within three standard deviations of the mean. So what we're going to do is we're going to use that information and we're going to answer a couple of questions. So here's one specific question. So when Rajani goes bowling, her scores are normally distributed with a mean of 125 and a standard deviation of 11. So we're going to use the empirical rule and we're going to determine the interval that would represent the middle 99.7% of all of her scores. So what you want to do is draw yourself a bell curve like this, a normal distribution, and then we're going to write down the mean. So the mean is 125, and the standard deviation in this case is 11. So smack bang in the center here, we're going to have 125. And then the standard deviation is 11. So if I add on 11, that means I'm going to get up to 136. If I minus 11, I'm going to go down to 114. So what that means is that 68% of the data, 68% of her scores will lie between 114 and 136. I can even go one more step and go two standard deviations above and below the mean. So if I add on 11 right here, I would get 147. And if I minus 11 right here, I would get 103. So when you're within two standard deviations, 95% of the data is going to lie between those two values. But in this case, we want 99.7. So 99.7% of the data lies within three standard deviations. So all we do is we add another 11 on again. So that's going to give us 158 for her score. And then we minus 11 here. So that'll give us 92. So 99.7% of her scores lie between 92 and 158. So that's basically how you're analyzing that information. All right, so let's go ahead and put those numbers in, make sure they work. 92, 158. Submit that. And look at that, we're correct. All right, let's do one more example. Okay, so for this one, we're talking about IQ scores. So IQ scores have a mean of 100 and a standard deviation of 15. But in this case, we want to know, well, what percentage of people have an IQ score between 70 and 130? Well, the way to answer that is like this. We know that we have 100 in the middle. That's the mean. Now, the standard deviation is 15. So if I go above and below one standard deviation, I'm going to be between 115 and 85. Now, between 85 and 115, 68% of the data or the population will lie there. So let's go one more standard deviation. If I add on another 15, I get to 130. And if I subtract another 15, I get 70. And those are the values that I'm interested in. So because I'm two standard deviations away from the mean on either side, I know from the empirical rule that 95% of the data will lie between those two values. So my answer is going to be 95%. So 95% of all people have an IQ score between 70 and 130. All right, so that's pretty much it. That's how you're going to be using the normal distribution and the empirical rule. If you have any questions, just reach out to us and let us know. Thanks very much, everybody. Bye bye.